everyone. Today we will discuss about the Euclid's geometry. Euclid's geometry, also known as Euclidean geometry, is considered the study of plane and solid shape based on different axioms and postulates. The word geometry comes from the Greek words geo means the earth and metrin meaning to measure. Euclid's geometry was introduced by the Greek mathematician Euclid, where Euclid defined a basic set of rules and theorems for a proper study of geometry. In this section, we are going to learn more about the concept of Euclid's geometry and the axioms and the postulates.
What is Euclid's geometry? Euclid's geometry was introduced by father of geometry, Euclid, and is also called Euclidean geometry. Geometry was originated from the need for measuring land and was studied in various forms in every ancient civilization such as Egypt, Babylonia, India, etc. Euclid's geometry came into play when Euclid accumulated all the concepts and fundamentals of geometry into a book called Elements. This book spoke about the definitions, the axioms, the theorems, and the proof of various shapes. Some of his fundamentals about solid shapes are: a point has no parts. A line is of breadth length. The ends of a line are points. A straight line is a line that lies evenly with the points on itself. A surface has length and a breadth only. The edges of a surface are lines. A plane surface is a surface that lies evenly with the straight lines on itself.
So next, let us proceed to Euclid axioms. So before that, what is axioms? Axioms is the assumptions used throughout mathematics and not specifically linked to geometry. So first of Euclid's axioms is things which are equal to the same thing are equal to one another. Example, if A equal to C, then and B equal to C, then A is equals to B. So this proves to axiom 1. Let us proceed to axiom 2. If equals are added to equals, the whole are equals. Let's look at this line segment AB. When AP is equals to QB, when PQ is added to the both sides, then according to the axiom 2, AP plus PQ is equals to QB plus PQ.
Next is axiom 3. If equals are subtracted from equals, the remainder are equal. Consider rectangles ABC, D, and PQRS, where the areas are equal. If the triangle XYZ is removed from both rectangles, then according to axiom 3, there are areas of the remaining portion of two triangles are equal. Next is axiom 4. Things which coincide with one another are equal to one another. If blue triangle is coincide with the rectangle, then they are equal to one another.
Axiom 5. The whole is greater than the part. If this circle is A, then this highlighted part is B. Here B is a part of A. Therefore, A is greater than B.
So we are done about axioms. The last part that we will discuss about Euclidean geometry is postulate. So what is postulate? Postulates, the assumptions specific to geometry.
What were Euclid's 5 postulates? Before discussing postulates in Euclidean geometry, let us discuss a few terms as listed by Euclid in his book 1 of the Elements. The postulated statements of these are: assume that 3 steps from solids to points as solid surface lines points. In each step, one dimension is lost. A solid has 3 dimensions. The surface has 2, and the line has 1, and the point is dimensionless. A point is anything that has no part. A breadless length is a line, and the ends of a line point. A surface is something that has length and breadth only. It can be seen that the definition of a few terms needs extra specification. Now let us discuss these postulates in detail. Euclid's postulate 1. A straight line can be drawn from any one point to another point. This postulate states that at least one straight line passes through two distinct points, but he did not mention that there cannot be more than one such line. Although throughout his work he has assumed there exists only unique line passing through 2 points. As you can see in this drawing, the two distinct points are P and Q, and there exists one line passing through the two distinct points. He did not mention that cannot be more than one such line. Although throughout his point, he has assumed that there exists only a unique line passing through two distinct points. Euclid's postulate 2. A terminated line can be further produced indefinitely. In simple words, what we call a line segment was defined as a terminated line by Euclid. Therefore, this postulate means that we can extend a terminated line or a line segment in either direction to form a line. In the figure given, the line segment EB can be extended as shown to form a line. Euclid's postulate 3. A circle can be drawn with any centre and any radius. Any circle can be drawn from the end or start point of a circle, and the diameter of the circle will be the length of the line segment.
Postulate 4. All right angles are equal to one another. As you can see, in my example, there are right angles whose measure 90 degrees are always congruent to each other. They are equal irrespective of the length of the sides or their orientation. Postulate 5. If a straight line following two other straight lines makes the interior angles on the same side of taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on the side on which the sum of angles is less than two right angles. So, here is the example of postulate 5.
That's all about Euclidean geometry. I hope you learned something about us. Please don't forget to like and subscribe. Thank you for watching.